Hello, and welcome to The Confident Commit, the podcast for anyone who wants to join the conversation on how to deliver software better and faster.
If you're looking to build a testing ship, tune in, let's confidently commit.
I'm your host, Rob Zuber, CTO of CircleCI, the industry leader for all things CI/CD. Today, I'm joined by Dave Farley. And I don't even know where to start with the intro to Dave. I feel like, as people who talk about delivering software better and faster, as folks working in the industry of continuous integration, continuous delivery and deployment, it would be shocking if Dave needs an introduction. But co-author of Continuous Delivery from 2010 with Jez Humble, and then more recently, 2022, I think, author of Modern Software Engineering, a book that I picked up and read recently and now recommend to literally anyone who will listen to me. Couldn't be more excited to have you here, Dave, to talk about all things software design, delivery, all of it. Thanks so much for taking the time to join me.
It's my pleasure. Thank you for asking me. I'm looking forward to it.
Yeah, great. Well, let's get right into it. There's going to be so much to talk about. I'm going to be struggling to wrap things up, I think, as we go on here. But just to kick things off, what I would love to hear about is, I just said I read Modern Software Engineering. I recommend it to everyone. I feel like we're very much on the same page in terms of how software should be designed and built. But I'm sort of curious, for me, I see the impact directly, right? I'm in an organization, I have a software engineering team, and I think deeply about how we build and how we deliver, and that our customers are doing the same thing. What is it for you that motivates you to get out there and talk about all this? I mean, you spent some time obviously in industry working on software, but what compels you to write books, to have your YouTube channel and really try to change the way that people think about software construction?
So I guess I came to that part relatively late in my career. I spent the vast majority of my career doing real work, really building software systems, and I loved it. I was lucky enough to find a thing that I had a passion for, and spent my career being paid to do it, which is pretty damn lucky. I kind of started writing almost accidentally. So Jez and I started writing the continuous delivery book, I don't know, around 2005, 2006. And largely the idea was that we were going to submit chapters, and there were a whole bunch of other colleagues that were working at the same place, a consultancy called ThoughtWorks at the time. And we thought it would be good. We'd learnt some really good things. You said you've seen the impact of this. Everybody that's tried this properly has seen the impact of this. It just works. And I can now, these days, I can point to organizations like SpaceX and Tesla and Microsoft and almost any industry you think of, and continuous delivery works better. So we kind of started learning these things and thought it would be nice to communicate them. So we started thinking about and working on the continuous delivery book, assuming that there would be a bunch of other people from similar projects to the ones that we were working on that would pitch in. And I had some stuff and I was writing away, and Jez hadn't got very much at the time, but then he started writing. And it turned out that we were the only two that were writing anything. So at some point we said, well, let's us do it then, rather than try and badger other people. And one of the things that I discovered about that was that I really enjoyed the writing experience. And I think more than that, these days with the YouTube channel and stuff like that, I started to think of myself in the latter stages of my career a little bit like the science communicators that you got on the telly that, convey, interest, Brian Cox talking about, or Neil deGrasse Tyson talking about, black holes and galaxies and things like that. And they make these ideas more approachable to other people. And I started to think of myself like that. And I started being a consultant, and then the pandemic hit and I was traveling less. And so I just went deeper into doing that kind of thing. And I kind of decided, when I started my consultancy working as an independent, I decided that one of the senses of job satisfaction that I would take is if I could polish the shiny stone of what's, my shiny stone that's part of the pile that represents software development, and help other people to see, better ways of working. I take a huge amount of job satisfaction from that. And I'm in the very fortunate position that I get communication every day from some means that says, we just tried that thing that you said and it works. And that's a pretty nice feeling. So I get a huge amount of satisfaction of, I suppose, paying back a little bit what I got from the industry, which was a great career.
Yeah. Well, that's so great. It's so great that people, write to you or whatever to tell you that it's working. I think, and that's a really interesting point. I mean, I think you mentioned in there, I don't think you used the word fun, but something about, once you try it, you see that it works, and it's I always refer to it as rewarding, fulfilling. And the other thing that you mentioned that I really like was sort of making these things accessible. Right. And so clearly, if people are saying, hey, wait a second, we tried this and it worked, like that feels like a game changer in some way. Yeah. And I'm sort of curious, what prevents people? I mean, I asked the question on LinkedIn of people, what do you want to hear about? And the first thing that came up was culture. Right. So what is it around? We have this understanding, we know these things work, but getting people to try them, getting them to understand them, putting them in an environment where that can happen. What really needs to happen for people to try it to get that realization, I guess?
I think that's a very I have some thoughts, but I think that's a very complicated question to answer. And it is certainly part of what I would think of as software development culture in the round. And that's for commercial reasons. It's for maturity reasons in terms of our thing as a profession. But I think in part, I think that for commercial reasons, I suppose, one of the ways in which we teach this stuff is just not very good. And I don't just put that at the door of universities and schools. I mean the way that we teach it in corporate environments as well. If you hire a civil engineer to go, career path is to go and build bridges or something, you don't put them in on day one onto building the bridge unsupervised. You have some kind of something like an apprenticeship program that brings people along and helps to grow those people into better engineers. So at some point you can trust them with building a bridge. I would say the same for software. Too many organizations, I think, try to hire people. You see the job adverts. We want you with this obscure technology, this particular way of working, and we want you to hit the ground running when you come in. And I don't want that. When I was hiring, what I was looking for smart people who could learn and maybe hopefully teach me something. That's what I wanted, because I think that's the core skill for software development. Is you want people that are engaged and great problem solvers. And so you need people that think like that and think about how to solve problems and are able to do that. When I was part of my career, the last but one full-time job that I had, I led a team that built probably the world's highest performance financial exchange using continuous delivery from day one. So it was a most wonderful experience of discovery and learning new things. But one of the things that we did was that we hired, forgive me being flippant, you can tell by, you maybe tell by my voice if you're looking, but I'm an old man now. But these were young kids straight out of university, fresh, but bright. And, we hired people, particularly young kids who didn't have any of the technologies that we used, had no experience whatsoever of doing test-driven development or pair programming, which is how we worked, knew nothing about finance. And we built some genuinely great software developers from them because they were talented and skillful, but we also helped them to learn. We invested in their learning. And some of them left and went to work somewhere else later, but that's okay. That's part of the game. And I don't understand why we don't do more of that. But the other thing is that, sorry, I'm jumping in, but the other thing that I think is that I think that, there's too much of software development that's about fashion. I'm using this framework, so I'm cool. I'm using this language, so I'm definitely on the cool kids table. And none of those things matter very much, in my view, in my opinion, in terms of building great software. You can build, it's not my preference, but you can build pretty good software with COBOL if you want to. It's a general purpose language. If you think about it well, you can do some good things. You can certainly do good things in old technologies these days, Java, C#, C++, Python, any of those things. They've been around for a long time. and that's not where the skill or the talent or the learning really is, but those are the things that we talk about all of the time. So I think there is this culture that makes it difficult. And one of the things that I think is problematic for us is that what that leads to is it leads to us, unlike more organized disciplines, I suppose, it prevents us from kind of building on the shoulders of giants. It's more difficult for us to learn something and then carry that forwards. Software changes all of the time, but it also goes in cycles all of the time. So at the moment, we're going through the revenge of the fourth generation languages, which was the 1980s version of no or low code systems. So is no code or low code? No, we've tried that already, and we know what it's good for and what it's not. And or at least some of us do that saw the cycle before, but we don't learn these things. We don't carry them forwards very well. So I think we could do better by having a few more guide rails that could kind of keep us on track for what really matters and what really works. And I think that would help people to develop their skills better and be able to pick some of these ideas up that really matter. And I think we do know now better than we ever have before what really works.
Mm-hmm. Yeah, I guess to all engineering leaders listening, teach your people to optimize for learning. Yeah. Right? I think that's the title of one of the sections in that book. But it's an expression that I love. And really, software is about change. I think, you mentioned civil engineering, even yes, there's some interesting parallels around how engineers are built in other disciplines. But I think the thing that is so unique about software is that you don't actually need a plan to start, right? Like you can't be halfway across a bridge and say, you know what? Oh, we forgot about big trucks. Let's make it wider and let's make it all these other like you have to start with a plan and be really clear about what you're going to build. Whereas in software, you have the opportunity to evolve as things change, and designing for that, thinking about that up front, I think is, to your point, the thing that we need engineers to be great at in this industry. Yeah. And I was going to ask you about that. I had the book open to this page that talks about focusing on, programming languages and IDEs and all these other things, but obviously it's top of mind for you. That's where we get hung up, as if that's going to solve the problem versus the fundamentals of sort of sound design and sound construction.
Yeah, absolutely, 100%. And those things haven't changed. They haven't changed since the 1960s, really, in many respects. The stuff, we didn't have the words for some of the answers. Terms like coupling and cohesion didn't come along until Ed Jordan came on a bit later than that. So some of these ideas have been around for a very long time, but we have got to the point where I think it seems evident to me that if you just stick to those few principles, doesn't matter what the technology is, doesn't really matter the nature of the problem, you will have a better chance of success if you do those things than if you don't. And that's what I was trying to get to in the Modern Software Engineering book, is what are those principles that we can always rely on and depend upon. And they're certainly the tools of my trade now. I didn't always think about it that way, but the LMAX experience that I mentioned earlier, where we built the financial exchange, that was a bit of a turning point in my thinking, because that was a problem that we knew going in was genuinely world-class hard, because we were being asked to do something that you couldn't look up on Stack Overflow. Nobody had a product that did this. There weren't simple answers to this problem. We were going to have to dig into some of the computer sciencey bits to try and figure some of this stuff out, and we did, which was enormous fun. But it was that kind of problem, and that made me think again a little bit about the relationship between engineering and software development. And going back to what you were saying about comparing it to other forms of engineering. I would argue that we often, I argue this in the book, but I would argue that we often mistake manufacturing for engineering. Engineering is building the factory. Engineering is building the process that's going to create the things. And so, and you can kind of see, one of the things that I'm fairly obsessed with at the moment is Elon Musk's Starship. And the engineering that you can watch live on YouTube, the refinement and the iteration and the development and the trial and error, blowing up spaceships and trying things out is very reminiscent of the kinds of things that we do when we're doing good engineering in software. But we have this huge, monstrous advantage that our cycles can be so much faster because software is so much easier to change.
Yeah. Faster, cheaper by I don't even know how many orders of magnitude, right? Like, what does it take to build a prototype of a desktop application versus a spaceship? I think whatever the numbers are, they're extraordinarily different, right? So taking advantage of that, I think, is one of the greatest tools that we have. But exactly to your point, it doesn't seem to be the thing that we're focusing on often. If you had to think about, I don't know, the state of the industry, right? You've been able to influence some small pockets. We see, we have many customers who are obviously really very good at building software, but is that the median? Is that like 95th percentile in terms of folks that are really sitting down and thinking about building software effectively? What's your perspective?
I think everybody wants to do it, but I think that lots of people, no, not everybody wants it. I suppose everybody wants to do it and everybody thinks that they're trying to do it, and lots of people are heading down the wrong road. That they're looking in the wrong direction. And I would, as a consultant, like everybody else, I'm kind of influenced by my filter bubble. As a consultant that goes in and tries to help usually large organizations improve their software engineering stance in various ways, my general impression is that average is kind of flaccid waterfall style Scrum is what average looks like these days. And they rarely do any of the what I think of as the engineering practices associated with agile development. So my take on agile history is maybe iconoclastic, I don't know, but I'd say that agile really primarily started with extreme programming, and then we had these other things that came in to try and make it more palatable for people that wanted to think about project management and protect their jobs. But then they threw out the engineering bits. So I think that's a lot of what modern software development looks like. However, the more hopeful view, I think, is if you look now at organizations across the world, almost any organization that you can think of or choose, who we think of as doing a good job in software development, they're nearly always at the heart got some of the sorts of stuff that I talk about and we talk about in terms of continuous delivery, continuous integration, test-driven development, trunk-based development, all of those things. Because they work, and these techniques have evolved independently several times now. So there's something deeply true about these things because they work. So while Jez and I were working on teams before we wrote our book that were practicing continuous delivery, Gary Groover and his team were working at HP, the HP LaserJet division, inventing continuous delivery kind of in parallel with us. We use slightly different language, we had slightly different focuses, but the techniques are the same. The ideas are the same. Continuous delivery, as I would describe it, I think of as kind of second generation extreme programming. So Kent Beck had done it earlier. We added some stuff onto what Kent Beck talked about, but there's this field of thought, and fundamentally, as I talk about in the Modern Software and Engineering book, I think that the reasons why these things consistently work is because at a fairly deep principles kind of level, really what we're talking about is applying scientific style rationalism to building software. So this is about, if it doesn't work, we change it. So we're trying to control the variables as strongly as we're able to. And so for that, we need to make progress in small steps with fast feedback so that we can learn more efficiently. And humanity doesn't have anything that solves problems better than science. And so why wouldn't we want to apply those sorts of ideas to software development?
Yeah, I think it's such a great connection. There's so many points that you've made in there that I want to try to bring together. But you talked about your own perspective changing over time. And so there's something about having to have seen things, tried things to ultimately say, oh, wait, no, this is better. Like I read Extreme Programming Explained, I'll just say very early in my career when the book was published, and thought, this can't possibly work because of the environment that I was in. And that's just not how we worked and all of those things. So maybe didn't feel like I had the ability to change things, or honestly just thought I don't know, you probably know, Kent, it's a bit late to change this, but I feel like the name of the book sort of like like Extreme Programming sort of just confused people, sounded like it was, the X Games or something like that. Anyway, so getting people to learn without having to go through, the same process that you went through over those years of trying things, doing things, and then saying, oh, wait a second, this is what really matters. I do think that's a sort of, cultural, structural thing that we need to figure out how to change. Otherwise, we're waiting for people to have been burned enough times, done things enough different ways that they finally, say, oh, okay, I get it, versus really creating that environment for them. And I'm not sure exactly what to take away from all that, other than, again,
just picking up on that idea, though, that's the problem. If every surgeon has to learn to wash their hands before they kill people, through contagion, by killing lots of people, that would be a bad thing for the progress of surgery. And essentially, largely, kind of, that's what we're saying that we're doing there. In order to be able to not do that, it seems to me, is that we must find ways of being able to rule out the dumb ideas. Let's say waterfall's a stupid idea for building software. Doesn't work, never worked. We've been trying to do that for 50 years to my knowledge. Doesn't work. Mm-hmm. And I still see people doing waterfall. SAFe is largely a waterfall process with a veneer of agile stuff over the top. It's, there are bits of it that are really fine, but overall it's a staged kind of process. And that's a problem because it doesn't work. It doesn't work. We've tried to make it work. We should be able to rule out bad ideas. And we can't even do that. So I tend to be a little bit more bullish in talking about some of these things than some people do, because you can't have an industry improve if every individual has a veto on every practice. We've got to be able to, we must be able to somehow say, let's not bother looking at that over there anymore because there's no good answers over there, until somebody comes up and shows us that there are good answers with some data or something. But we do things too much on opinion, and so it's one of the reasons why one of the key ideas really in continuous delivery circles, I'm sure that this you're deeply mired in this yourself, is the DORA metrics that we have, for the first time in the history of software development, as far as I can find, a properly defensible set of research into software development practices. And they say that the stuff that we talk about, continuous delivery, works better than anything else. And yes, it's nice that it validates my opinions, but where it doesn't, I'm going, okay, so why are my opinions wrong, and how do I correct them? I'm not saying, oh, I'm just going to ignore it because it doesn't fit my worldview.
Right. Yeah. I mean, I think that yes, it supports, I'm going to stretch this a little bit, but yes, it supports continuous delivery. But I think what it really supports, the notions support that better business results are achieved by being prepared to learn and adapt. Right. And I don't know that should be surprising, but I think it's one of the biggest obstacles to acceptance in many organizations, which is that sense that being wrong is a failure. I often say that the last 25 years, which is the part of software delivery I can account for, has been entirely dedicated to accepting that we are wrong. Yes. Right? Whatever it is that we think, we're going to be wrong about it. And so we're shortening the cycles to figure out how and why we're wrong so that we can start going in the right direction. And when you embrace that, it fundamentally changes the way that you think about building and delivering software. But waterfall is about resisting that, right? It's about saying, if we write more documents and more people sign them, then we will be right. Yeah. Does that make sense?
It makes sense, absolutely. And you use subtly different words to the words that I use, but that's something that I say all the time. I just going back to where you started on that riff. I tend to use the term continuous delivery loosely because I think that continuous delivery is the enabling factor for allowing us to do that. So it's not that I think that those are separate things that the Dora metrics are measuring. So I'm sorry if I was being lazy in my language, but absolutely. I think that's one of the core ideas. You know, I think agile, we can broaden this not just to continuous delivery, but agile in general is about, let's start off assuming that we're probably wrong because all of the evidence suggests that that's going to be true. So what we're going to optimize for is allowing ourselves to be wrong, detecting where we're wrong very quickly so that we can recover from being wrong very quickly and try something new. And as you say, very profoundly, the reason why I can dismiss waterfall, and I believe that I'm a pragmatist. I believe that I have an open mind. But the reason that I can dismiss waterfall is because it starts off assuming that we must get things right first time. And human beings can't do that. Like one of my favorite examples is of this in another engineering discipline is the evolution of the aeroplane. In the early, the aeroplane is a little over 120 years old, thereabouts. And in the first couple of decades of the aeroplane, nearly every pioneer of the aeroplane was killed by the aeroplanes that they were pioneering with, because they were death traps. They would kill people. And in 2017, nearly 3/4 of the population of the planet flew in a commercial airliner and nobody was killed. That's astonishing. That's astonishing. That's how safe they've become. Sitting in an aeroplane, you are safer than you and I and the audience are sitting here taking part in this podcast. That's ludicrous, but that's what the statistics say. Yeah. That's what engineering does, and that's what iteration does. So if the Wright Brothers had to start off being right first time, they'd still be writing design specifications for a Boeing 747 in 1903.
Yeah. It's so fascinating to me because I've used these words before, but like it's more fulfilling, it's more enjoyable as a software developer, as an engineer in any form, to sort of embrace that and work with it, right? Find a way to move forward. And so I think it's I keep calling out the engineering leaders that are listening. I mean, that's the big takeaway, right? Because it's about the environment that you create and creating that opportunity for folks to realize, hey, you know what? We know that we're going to be wrong. That's the goal, is to figure out how to be right. And the way that we do that is by, iterating, by learning. That's the job. And I recently have been, because I throw around the word failure, like it's nothing. It turns out that's not the way everyone thinks about it. So I've started trying to substitute hypothesis, like, basically, we're just testing something. We don't know. We're pretty sure it's wrong, but we think maybe this will help. Maybe this will help. Let's try it, see what happens. But then that means, back to the software design thing. And what I love about this book and what I've been thinking about a lot lately is the correlation between rapid delivery and software design. Like if your software is not designed in a way that allows you to easily change, then everything else gets infinitely harder and you lose the ability to adapt and learn. Speaking of change, I'm going to shift topics a little bit, but I'm going to find a way to connect them because our entire industry feels like it's changing at the moment in the world of, AI, which is however many years old, so old, yet overnight success in terms of, generative AI, OpenAI sort of dropping at the end of last year. And one of the things that I find particularly interesting, there's so much that's changing, but is how we're thinking about what that means for software developers, right? And there's a few different avenues there, but one that I'm particularly interested in is the number of people who believe that we can make software engineering easier by automating the writing of tests, which I think is really fascinating because, you're obviously a big advocate of test-driven development, of using test as a design tool, right? So we just said the way to deliver software successfully is to have great design. One of the best ways to have great design is to validate your thinking or enforce, good design practices through the design of your tests. And so that feels like an indicator that we're not thinking about testing in a way that's going to give us the most benefit, if that makes sense, because we're thinking, that's the first thing that we can sort of get rid of. I would almost go to the other end and say, what if we just wrote really great tests and let AI build the software because the tests have already told us exactly, what we need, sort of thing. So I'm curious what your experience has been, how you think about that sort of, automated test gen piece, and where you think this is taking us as software engineers.
I'm very firmly in your camp on this. I am not an AI skeptic. I believe that one day, it makes me nervous, but I believe that one day AI will. There's nothing technical. There are no technical barriers to learning machines learning to be smarter than us. I believe that what we are building, the reason why it's suddenly taken off is because we are starting to use evolution. These are self-learning machines. We are teaching machines to learn, and they learn at a rate that's faster than us. So, I'm not skeptical. It's not that I don't think they'll ever be smart enough. That one day they will be writing all of the code, and we'll have bigger problems to think about then, rather than programmers not losing their jobs, because they'll be doing everything that human people can do better than humans. So we'll have to figure out how society can work in those sorts of regimes, I think. But certainly in the immediate future, when we're talking about things like using AIs to write the test, that seems like that seems like a naive way of thinking about it to me, because all that you can do, if you've already got the code, this is true of humans or computers, all that you can do if you've already got the code is validate that the code does what the code does. If that's your only point of reference, if it's a human, at least they've got some idea, as well as the code, of what's meant to happen. But, if you've got a code with a big bug in it, how does the AI know that bug's not supposed to be there, and just writes a test that proves that the bug's there? That's a silly example perhaps, but it's a self-referential system. So fairly deeply there are big problems with those sorts of self-referential systems. And I think this is the fallacy that's very common in parts of our industry in terms of thinking that typing's the problem. Typing's not the problem. Thinking's the problem. And I have a video out on my YouTube channel this week, which is about me just playing with GitHub Copilot and talking about the pros and cons of that. And there are some things that are nice about GitHub Copilot, and there are some things that are just not helpful. And ultimately, when it comes down to it, one of the things that you can do with GitHub Copilot, for example, is that you can write comments that describe behaviorally in English or some other human natural language the kind of thing that you want, and it will start suggesting code for you. And at that point, I'm programming. And actually, I'm programming in a language that's less precise and more ambiguous, and so it's harder for it to get the right answer than if I wrote that in Java, and now I'm just programming again. So I'm a bit skeptical about some of those things. I think they can be useful tools. I think they can be helpful in the kind of prompting your memory that this is how you use this API, or this is an algorithm for this. I found it less and less helpful as I was doing less and less common things. I consciously tried to do something that was a little bit different. I tried to write a JUnit plugin and it wasn't really much help at all in assisting me to do that. So I had to back away and find a simpler way of doing it in order to allow GitHub Copilot to do the work for me.
Yeah, I think I mean, the whole space is obviously fascinating because we don't know, right? We don't know what's going to be achievable, what's not, what's going to be really valuable, what's not. But for me, the thing that I spend a lot of time thinking about, again, to the point of the testing or otherwise, is design, right?
Yeah.
And we talked about how important it is for junior engineers to be learning. This isn't about this toolkit. Don't just learn the syntax. It's about good design. And does this shift us, the ability to just sort of generate a pile of code? Oh, that was easy. It works. It does the thing. Sort of turn off that thinking part of our brain that's really driving for great design and sort of send us on I don't know if it's the wrong track, but on a different track that like we end up paying for somewhere down the road, I guess.
No, I think that's, and I think, again, this is going to get boring because we just keep agreeing, but all
right, I'll find something contentious.
but absolutely, this, and I think that's the mistake. And again, you were talking about Kent misnaming extreme programming earlier on. Maybe you got test-driven development wrong as well, because it's not. I don't think it's about testing really. That's not the primary value here. And I do know Kent a little bit, and we had an interesting chat, and he says, yes, but the tests are really valuable, and he's absolutely right. They're really valuable, but I still think that's a secondary value. To me, at least, I am a long time practitioner. Like you, I had a bit of I thought extreme programming, that sounds a bit weird when I first heard about it, but actually within a matter of months I was doing it, and actually this is really good. So I've been doing it ever since, really, in one form or another. So I'm a fan. I'm a believer, and I'm a believer because exactly what you said. It's the best tool that allows me to focus on design, better than anything else that I know, better than ChatGPT or Copilot or any of those tools. Test-driven development is better than them at helping me to design a solution. Because I can design solutions that they can't do with test-driven development, and I can do it better. Mm-hmm. I did do the experiment of trying to give them tests, one of the LLM's tests at one point, and it kind of worked for simple things and didn't work later. but that idea, the test-driven development is one of those key guide rails that if you start off by defining what the behavior that you'd like from the piece of software that you're trying to write and capture that in an executable form, which is what test-driven development does, then that splits the design process into two bits. Thinking about the functional need of this piece of code, and then thinking about how you're going to meet that need. And that's designing the code itself, developing the code itself to meet that need. And that gives us a remarkably powerful tool that allows us to go much faster, at least in my experience, and with much higher quality in nearly everybody's experience, than without.
Yeah, I think that the big thing on speed that I always take away from that, because I've been in the same role for over 9 years, so you get to see things over time, is sustained velocity, right?
Yes.
And I'll use velocity cautiously because I don't mean story points or whatever, but like throughput, pick your word, they've all been burned for something. But the ability to, there's always but I can get this done faster if I don't do that. But this is about the ability to continue to deliver because you haven't created this complex morass that you're afraid to change when you actually need to come back and do something later. So let's go a little bit higher level. You keep talking about design, and I'm cheating when I ask this question because I already asked you. But as an author, are there any other books or a particular book that you find yourself recommending to folks that isn't one of yours, which everyone should obviously read?
Yeah, of course. So there are several books in that list, and I do have a video on my YouTube channel that lists a few of them.
Perfect.
But I think top of my list is, and has been for a very long time, it's actually a bit of a tricky book, but it's fantastic. It's domain-driven design, And it just aligned so nicely with the way that I thought about design. It's the book that I most wish that I'd written, Domain-Driven Design. It just captures what I think is good design, and it's all about this kind of modelling of the problem. And I don't mean this in sort of some diagramming technique or something like that. It's the deep idea of trying to crystallize our thoughts, our ideas about something into a form that we can revisit, understand, use to navigate something that's complex and sophisticated, maybe in terms of the problem. And domain-driven design does that. And there are so many wonderful bits about it. If anybody who hasn't read domain-driven design goes and reads it, I will offer you some advice that you'll thank me for later, I think, which is there's a middle part, and I know Eric Evans, he's a friend of mine who wrote the book, and he says if he was writing it again, he'd probably reorder some of the chapters. So I'd advise you to read the first third and the last third, and only then the middle third. So that the bit on strategic design is genius. It's fantastic. It's just there are so many great ideas in there, and lots of people don't get to it because the middle part is really good. There's some really good stuff in there, but it's just a bit hard work. It's hard. It's a bit dense. And so I'd read the stuff on strategic design.
This is going to be a huge distraction, but I feel like you could be describing the Lord of the Rings right now. I'm not like the middle section has some great stuff, but it's
the
like
Tom Bombadil bit.
But I think it's true of because there are other authors who have come back and tried to approach domain-driven design. I read one. Is it Von Vernon?
Von Vernon,
yeah. And the same problem exists, which is every piece of domain-driven design is foundational to every other piece. So figuring out the sequence in which to present them, I think, becomes really challenging. And so I think that's a great bit of advice. I mean, read them in different order. Maybe also recognize that you're going to hear some terms and not really know what they are, but they're going to come back later, and that's okay. Sort of like immerse yourself, enjoy the experience. And I would totally agree. Like that is such a foundational concept to helping you think about what matters in your software and, things that will change together. We talk about, optimizing for change, optimizing for learning. There's so much great material in the world of domain-driven design. And I think it's a massive, massive contribution to our whole industry. You said there were others. Is there anything else that you want to highlight?
Yeah. We've already talked about one of the books that was kind of foundational for me, which was Extreme Programming. Like you, when I started out, I was working on a really good team. We were doing some good things. We were very agile, and we didn't know that it didn't have a name then. So we were a very small team doing some cool things. And we're having lots of fun. And there was a very young, enthusiastic member of the team, the kind of person that was just a delight to work with because he was permanently bouncing off the walls because he was so full of energy. And he came in, he said, Dave, we need to do extreme programming. It's wonderful, because he just read this book. And so we spent the rest of that day just taking the mickey out of him because he was promoting this stupid sounding idea of extreme programming. And then I did read the book because he was a smart kid. And I thought, there's some stuff here. I don't like the language, but there's some stuff here. And I'm not the kind of person that has heroes, but Kent is probably close. I would embarrass him because I do know him a little bit, but I would embarrass him. But he's close to one of my heroes, as I have heroes. I think Kent has a wonderful way of seeing the simple in the complex. He wrote the first version. I couldn't really understand extreme programming until I saw JUnit, and then I go, that was the light bulb moment for me. He wrote the first versions of I don't know whether he wrote JUnit first or a Smalltalk version. I can't remember, but he wrote it on an aeroplane ride. I mean, it's. I could probably do that now that I know it, but he was inventing it while he was doing that.
Mm-hmm.
That's pretty good. He's a smart guy, and one of the things that I like about that is that I could write it now from scratch because it's so simple, and that's because you don't need anything. You don't need anything big and complex. Before then, test frameworks, I remember, were big and complicated, and after then, everything, we just got an X unit for everything, and that was a better way of doing things. So there are lots of those sorts of things, and I think of a lot of my work I think is built on the principles that I picked up from extreme programming. Amongst others was that idea that you were talking about in the context of domain-driven design, is that all of these things intertwine. So test-driven development works best if you're doing continuous integration, which works best when you've got shared code ownership, which works best when you've got pair programming, and so on and so on. And all of these things reinforce one another and build on one another. Mm-hmm. And so I think my stuff, continuous delivery and modern software engineering, are probably kind of second and third generation extreme programming largely.
Yeah. Well, all these ideas building, you said standing on the shoulders of giants earlier, like these ideas build on each other. If I struggle sometimes when people ask me for recommendations or what, I just like read all of this stuff. Well, where should I start? Any of it will probably be a great place, honestly. It'll open your eyes. And I think, you described something in your sort of view of extreme programming, which there's a couple funny things in there. One, totally discounting it and then reading it and going, wait a second, I think there's something here. But two, read these things, read anything. And you don't necessarily have to agree with everything in there, but there's always going to be something that's going to open your eyes, open you to a new way of thinking. Take that and try it, learn from it. Continue to grow.
There's another book that was going through the back of my mind when you were asking me about books. This is a much older book, so I was in at the very, very early days of programming for Windows. I learned to do Windows programming on Windows version 1, which didn't have overlapping windows. It was just it was a bit weird, very simple compared to what came later. But there was a book, there's a guy called Charles Petzold who wrote the book on Windows programming in those days. And Petzold, you could tell a Windows programmer because they could recite parts of Petzold, because it was that kind of book. And I learned not only Windows programming, but actually, in a weird way, quite a lot about event-based programming and object orientation from the Petzold books, which kind of later came back in different ways. So I think reading a lot of these ideas, exposing yourself to stuff that you haven't thought about before or haven't tried before, I think is, if you're really interested in software development, is a good idea for broadening out your skills and building your mental toolkit. I find that I am picking ideas from all over the place. Some of them computer science, some of them just bits of software that I saw, and all sorts of things when I'm working. But I think that's the nature of any complex discipline, I suppose.
Yeah, one of my favorite books actually outside of software is Range by David Epstein. He talks about analogical thinking and sort of how metaphors or analogies from other disciplines help you come up with new solutions. And so, yes, broadly across different software disciplines, to your point, learning event-based programming because you're thinking about Windows, like whatever it is, go out, try different things, explore different things. If you are I am a person who builds this kind of system in this language sort of thing, you'll never really be able to have new creative ideas, I think, in that space, because you're sort of just like, I do it this way, I always do it this way, and this is what I know how to do. And honestly, like I always talk about fun and fulfillment. Like it's fun to learn new things. It's fulfilling to try, explore different domains or like bring in new concepts that'll
I am actively the kind of person I like a challenge. I like trying hard things sometimes. So my story, going back to the example I mentioned a couple of times now, LMAX, where we built one of the world's fastest financial exchanges. It's kind of funny how I got that job. I was working in a dream job. I was the lead tech principal in the UK for ThoughtWorks. I could work on some cool projects. I was advising on ThoughtWorks were a lovely company to work for, certainly at that time. And I was having a lot of fun. I got friends there. And one day I got a phone call from an old friend of mine who's a great programmer. He said, do you want to go out for dinner? So we went out, and I thought I was trying to sell him ThoughtWorks consultancy, and he was trying to recruit me. So we went out to dinner, and he said, we've got this problem and we don't know how to, he knows me quite well. He said, we've not got this problem. We don't know how to solve it. And I said, He said, and I don't think anybody knows how to solve this. Nobody's ever done this before. And I'm going, ooh. and he says, we're backed by, Betfair, sport betting company's money at the time. So it's quite well funded. And if it's successful, we might make a lot of money. And I'm going, so all of those things just stacked up. But it was absolutely, the hook was here's a really hard problem that we don't know how to solve. Because isn't that what we're here for? To have those cool problems, to be challenged and to find out interesting ways to solve them. Certainly what I'm here for.
Absolutely. I think, that's our whole industry is full of them in so many different ways and places. And it's a fun story. I'm going to have to call it a fun story to end on. I said, at the beginning, I was going to have trouble drawing this to a close. It's dark in your background now, which I feel really bad about. So, I could talk to you all day, Dave. This has been amazing. Thanks so much for joining. Thanks to all our listeners for listening in to the episode. If there's someone you want us to talk to or something you want us to talk about, find us on Twitter at CircleCI. If you enjoyed the podcast, share it with your friends, subscribe where you get your podcasts. Dave, again, thanks so much for joining me. It's been such a pleasure.
It's a pleasure. Thank you for asking me. And thanks to everybody for listening.
If you like what you heard today and want to learn more about building, testing, and delivering AI-enabled software, we've gathered all our best resources and tutorials into one place. Go to circleci.com/AI-ML to explore and start learning.